In this video, I'd like to talk about pencil cut. A pencil cut is the ability to drive a tool along the intersection of two surfaces. To get to pencil cut, we're going to go to NC, down to 3-axis, and move down to pencil cut. SURFCAM asks us to select the cut surfaces, and I'm going to choose visible. I'm going to select a ball nose end mill, so I'll click on the ball nose icon and choose a 375 4-flute ball. Click OK, and we're asked for tool number, length offset, and diameter offset. Make sure these numbers are appropriate for your program. I'm going to go to cut control, and we're going to look first at step over. Step over is the distance between passes. I'm going to give it 20 thousandths. You see here we have an XY stock to leave and a Z stock to leave. You can leave this at 0 if you want to cut to finish size, or add or remove stock by putting in positive or negative numbers. We can also put in extra stock to leave, which essentially increases the diameter of the tool that you're using. This makes it possible to use a smaller tool on a larger radius. Our angle ranges from 0 degrees to 90 degrees. I'm going to accept that for now. The other thing we want to look at is down here at the bottom where it says limit offset passes. We're going to have 5 passes on either side of a centerline pass. All these passes work from the outside in, which means that you're going to remove material in the most efficient manner. I'm going to click OK, and we're going to see what we get. Here's what our pencil cut looks like when completed. If you recall, we asked for 5 offset passes. And if we zoom in, we can count those 5 passes on either side of the center line. Here we have 1, 2, 3, 4, 5. Here's our center line pass. And then 1, 2, 3, 4, 5 on the other side. Another thing to look at here is the high-speed machining moves as we enter and exit the material. This will provide you with a smoother blend into the part and speed up your machining process. If we want to see how the pencil cut works in real life, we can go up to Backplot, select our pencil cut, click OK. Then I'm going to adjust our slider bar here to increase the speed of the simulation, add a tool holder, and press play. Here the pencil cut is coming in from the outside, going around the majority of the part. Now we're cutting one of the sides and the other side. You see all of these passes occur from one side of the center line or the other, all with high-speed moves. I'd like to point out a couple of things in pencil cut by going to our Operations Manager and regenerating our toolpath. If we go to the Cut Control tab, I call your attention to By Tangency Angle. What this means is the shallowest angle between two surfaces in which you'll be able to make a pencil cut. If you increase this angle to 30 or 40 degrees, you'll limit the number of choices you have for making a pencil cut. Secondly, if we go to Leads and Links, we see our cutting direction is one way. This does not guarantee that you'll get a climb cut. If you make the passes and see that it's not climb cutting, what you can do is click on the reverse direction button and it will reverse the direction of the one-way cut. So if you don't see what you want the first time, click reverse direction and try it again. The other thing I'm going to do is change our retract strategy from full retract to shortest route. I'll click OK, OK again, and we'll regenerate. Here's our pencil cut with the reverse direction and our shortest route ramping strategy. I want to show you one more thing. I'm going to zoom up in here and see our 5 passes on either side of the center line. I'm going to go up to Operations Manager and regenerate with original geometry. Go to Cut Control. I'm going to limit the number of offset passes down to 0. I'll click OK and we'll see what happens. As you can see, after changing the number of offset passes to 0, we have 0 offset passes on each side of the center line. What we have is just the center line, so we will get a single pass that's tangent to both surfaces all the way around the part.